For over a century, the logic of building cars has been ruled by a single, unyielding concept: the fixed conveyor belt. It's a system built for maximum efficiency, but it requires a rigid, linear sequence that physically bolts the manufacturing process to the factory floor. Today's automakers face a volatile market, where consumer demand swings between traditional gas engines, hybrids, and fully electric vehicles. If a company guesses wrong on which models to prioritize, retooling a traditional fixed line to meet that new demand requires weeks of total factory downtime and hundreds of millions of dollars in mechanical overhauls. Mercedes-Benz spent 730 million euros building Factory 56 in Sindelfingen, Germany, specifically to dismantle this century-old mechanical trap. The resulting 220,000 square meter facility enables the massive V12 combustion Maybach, standard gasoline sedans, and the fully electric EQS to share the exact same production sequence. Transitioning to a carbon-neutral fleet requires a format-agnostic infrastructure, one that outlasts the specific engine types it currently produces. To make this level of manufacturing flexibility possible, engineers had to rip out the foundational element of mass production, the continuous track. The plant replaced the traditional chain with over 400 automated guided vehicles, or AGVs. Instead of a single belt dragging every chassis forward at a fixed speed, the vehicles sit on freely roaming nodes that navigate independently. Guided by magnetic floor strips and optical sensors, these autonomous platforms fetch specific shopping baskets of parts. If one workstation takes longer for a highly customized interior, the surrounding AGVs dynamically detour around it without holding up the rest of the fleet. The heavy robotic automation is now grouped into isolated modular hubs called the tech line. These dense clusters of machinery are no longer spread rigidly across the entire building. By confining the complex robotics to a few specific zones, plant managers can update the machinery for a completely new car model without tearing down the rest of the factory floor. Letting 400 autonomous vehicles loose inside a single facility would instantly devolve into logistical chaos without a massive, real-time data network to coordinate them. To prevent collisions, Mercedes installed a dedicated 5G cellular network directly inside the building. This high-speed web blankets the floor, allowing every vehicle, part, and robot to constantly broadcast its exact location and status. This data network extends all the way down to the individual hand tools. When a worker picks up an internet-enabled screwdriver, the tool scans the digital signature of the chassis waiting in front of it. It instantly recognizes whether it's working on an EV battery or a dense gasoline engine and automatically adjusts its torque to match the exact specifications. Every rotation of that screwdriver is logged on the factory servers. This creates a permanent, highly searchable digital twin of the assembly process, where the tightening of every bolt on every car is recorded for future safety analysis. The ultimate test of this system happens at a station the automotive industry calls the marriage, the critical moment the completed car body is bolted onto the powertrain. This animated wireframe illustrates the geometric problem at hand. A traditional powertrain features a heavy, cylindrical combustion engine bolted to a 5-meter-long axle. But an electric vehicle utilizes a wide, flat slab of lithium-ion batteries that spans the entire underbelly of the car. Under the old manufacturing model, bolting these vastly different structures together required entirely separate assembly lines. Here, identical hydraulic platforms adjust their robotic attachment points on the fly to match the incoming chassis, locking the specific mechanical guts into the matching shell overhead. Executing this multi-format marriage without interrupting workflow proves that structural differences between combustion and electric drives are no longer an insurmountable manufacturing bottleneck. The sedans rolling off the line are packed with dense digital electronics, including an intelligent headlight system that uses over 2 million microscopic mirrors to project complex warning symbols directly onto the road surface. While the S-Class continues its history of insulating world leaders and heads of state, the primary innovation now lies in the architecture of its assembly. Factory 56 operates as a definitive proof of concept for Industry 4.0 manufacturing, where heavy mechanical labor is directed by a hyper-aware digital brain. As the global economy leaves fossil fuels behind, the automakers that survive won't be the ones constantly demolishing and rebuilding their physical infrastructure. Instead,
They'll be the ones whose factories simply download a software update and start building the next generation.